In 1958, the 20 series passenger cars were introduced alongside the 20 series EMUs, and they revolutionized the concept of overnight trains, earning the nickname Running Deluxe Hotel. While passenger cars had previously been equipped with air conditioning and lighting, each car individually drew power from its axles, limiting the available power and cooling capacity. At that time, electrified sections of the railway were still short, and even the Sanyo main line was largely unelectrified, making it impossible to rely on power supply from overhead lines. Therefore, a dedicated power car equipped with diesel generators was prepared to supply air conditioning and heating power to each car in a formation of 10 or more cars. A generator with approximately 700 horsepower was required. The DMF-31 engine, produced for the DD-13, was modified for power generation, with its rotation speed reduced to 1200 rpm for 60 Hz three-phase AC, and the output was lowered to 340 horsepower. Two of these engines were installed. Each engine weighed 3.1 tons, and the generator weighed 1.5 tons. Including auxiliary equipment, the total weight exceeded 5 tons. With two engines installed, the car became significantly heavy. Therefore, in the first generation Mani 20, the body length was reduced to 17 meters to control the weight. Despite significant noise reduction issues, the first centralized power supply system was started. On the other hand, there was an extremely high demand for newspapers at the time, with railways playing a major role in their transportation. Newspapers for the Kyushu region were printed in Tokyo and sent by sleeper trains that arrived in Kyushu the next morning, playing a crucial role. As the economy grew, the demand for newspaper transportation also increased, and the need for luggage transportation continued to rise. To meet this demand, the Kani 21 was introduced as a 20-meter car with a larger luggage compartment to increase carrying capacity. Amid favorable reviews, the 20 series sleeper trains were expanded, and they began running to Kagoshima. As electrification proceeded smoothly, the Sanyo main line was about to be electrified up to Hiroshima. However, there were doubts about relying on diesel generation over long electrified sections. There was a demand for power cars that were free from noise and exhaust issues, easier to maintain, and had lower maintenance costs. To effectively utilize power from overhead lines, a compact power car with a 13-meter body length, equipped solely with a motor generator set, was considered. Additionally, adaptation for AC was also contemplated. However, the incorporation of two types of power cars in the formation was deemed impractical as it would lengthen the train and complicate handling. Consequently, the motor generator was installed in the Kani 21, and the adaptation for AC was abandoned. In today's terms, the term motor generator might sound odd. However, at that time, there was no device to easily convert large power high-voltage DC to AC, so it was common to use a DC motor to drive an AC generator, an approach that could be seen as somewhat straightforward. This led to the introduction of the Kani 22, which was equipped with 4 generators, 2 diesel generators and 2 motor generators. To collect power from the overhead lines, 2 pantographs were installed on the roof, and with the same vehicle cross-section as the 20 series passenger cars, it had quite a commanding presence. In a descending train where the Kani 22 was coupled directly behind the locomotive, it created an impression of a double-heading hall, presenting a majestic scene. Of course, in non-electrified sections, and since it was dedicated to DC, the pantographs were lowered during AC sections. Raising the pantographs in an AC section would be a serious issue. A double lock mechanism was provided to reduce the risk of operational errors, and the operation of the generators and pantographs could also be remotely controlled from the locomotive side. Although the Kani 22 debuted with high expectations, it faced significant challenges in expanding to local lines. The motor generators operated at 1800 rpm, faster and lighter than the diesel generators. However, the installation of 4 generator sets was substantial, and the empty weight reached 59 tons, with a loaded weight of 64 tons. Even on main lines, the many local lines with lower standards imposed speed restrictions, hindering optimal operation. Despite being a sleeper train, speed restrictions on an express were unacceptable. As a result, the initial plan for use on the Hayabusa was abandoned. With the opening of the Takedo Shinkansen, the expansion of 20 series sleeper expresses into local areas increased. The weight of the Kani 22 became even more of a hindrance, and it was treated as an inconvenient vehicle. A drastic measure was taken, the removal of motor generators and pantographs. Most of the operational service was carried out without pantographs, relying solely on diesel generators. Aiming for low noise, fuel efficiency, and reduced maintenance costs, the Kani 22 was designed as a dual-mode power car in modern terms. However, the low track standards prevented it from performing to its full potential, and it spent its later years unable to fully showcase its original capabilities.